All right, guys, we're going to look at slide number 10 right now. And slide number 10, I'm not going to have up on the screen with me simply because I just write down what we're doing. So we're going to start with reduction. We have reduction and oxidation. Remember, reduction is the addition of a hydrogen. Oxidation is the addition of oxygen. Or reduction is removing oxygen and oxidation is removing hydrogen. Two different ways to think about this. So first, we're going to talk about reduction. All right. If you remember, we can reduce an alcohol, or excuse me, when we can reduce an aldehyde, and when we reduce an aldehyde, we get a primary alcohol. So this is glucose. We can reduce glucose to this right here. This is sorbitol, which is a sugar-free sweetener, simply because it's not glucose anymore. So we have this. We've reduced it. We've reduced the aldehyde to a primary alcohol. Here, if we have xylose, this shouldn't be a big deal. Again, in aldose, we reduce it and we get a primary alcohol. And that's it. Now, oxidation, carbs that are oxidized are considered reducing sugars. I didn't come up with the name. Oh, excuse me. All right. Ketones can be oxidized because the carbonyl group rearranges. If you remember, we cannot oxidize a ketone. So here, this is glucose. Can we oxidize glucose? You betcha. The aldehyde group is oxidized to a carboxylic acid. So from here to here. This is going to play a major role once we get to the citric acid cycle. There we go. Here, if we're oxidizing a ketose, this is a little bit different. What we get is, sorry, I'm going to move my face a little bit here. There we are. You have your ketone here. That ketone rearranges into a aldehyde. We have a rearrangement into an aldehyde. Once it's in the aldehyde form, it can be oxidized and you get your carboxylic acid. This is how ketoses are oxidized. We go down here, threose. This is an aldose. It's oxidized. There's your carboxylic acid. Erythrulose. All right. This is oxidized and it becomes the same thing. Both L-threose and D-erythrulose. Well, they both end up being carboxylic acids. So we have this. Everybody with me? Hopefully, great. Here, D-arabinose. All right. You are going to have to walk through and try to do this yourself. We can reduce the aldehyde going this way, and we're going to oxidize the aldehyde going this way. So that's something I'm going to have you guys do on your own.